right. Okay, so standard form is y equals ax squared plus bx plus c. And any quadratic function can be written in that form. So if we look at these guys, is the first one on the left a quadratic function? Yes. Okay. It does. It is a polynomial that all the exponents are whole numbers on the variables, and x is to the power. We need at least x to the power of 2. Okay, that is it. Even though there's no x there, that's okay. We have x squared. It's a quadratic. How about the next one? Yes. Yeah, could it be written in this form up here, ax squared plus bx plus c? Yeah, if we expanded it, FOIL out x minus 2 squared, x minus 2 times x minus 2, yeah, it can be written in that form. That is a quadratic. It's currently in what form? What do you call that? We've been doing for 2 days. Vertex form. Good. Okay, the next one, y equals x minus 3. Yes or no? No, what is it? Linear. Degree 1. How about the next guy? Is that quadratic? Could I get y by itself here? Yeah, I subtract, move the 2x squared by subtracting it to the other side. Is that a quadratic? Sure is. So we can circle that one. All right, top right. Yes or no? What's wrong with it? Power of 3. So the highest power in a quadratic will be a 2 for x, and this is a cubic. X times y equals 8. So if we isolate y, that might tell us. How would I isolate y? How would I get y by? Divide both sides by x. And so this equation becomes y equals 8 over x. Is this a quadratic? No. Does anyone remember what it's called? We're going to study a whole unit on them. Yeah. Yes. That's a rational equation. Next guy. Yes or no? No, what's wrong? There can't be a square root. So a square root is the same thing as x to the power. You could also write this equation as x squared plus x to the power of 1/2. Do you remember that from 10C? Power over root, right? The exponent is 1, the index is 2, so it'd be 1 over 2. All our exponents have to be whole numbers. That's not a whole number, so it's not. This would be a radical equation, obviously, because there's a radical in it. Next guy, yes or no? Yes, sure is. Okay, so those are our quadratics. Okay, so what we're going to do is comparing it to standard form, y equals AB, no, not AB, ax squared plus bx plus c. Okay, we're going to state our a and c value, graph them, and then determine a couple things. Now we could probably easily do the first 3 right now. So looking at this first equation, what is the a value? Just by looking at negative x squared plus 7x plus 2. Negative 1. And so because the a value is less than 0, what direction is it? Down. Okay. What is the c value here? Would be 2. C is your constant. That's kind of nice that it starts with a c and it's a constant. It's a coincidence that it's a c. But c is the constant, and so in this case, what's your c value? It's positive 2. So grab your graphing calculators. Let's quickly graph this and see what our y-intercept is. I wonder if I can right click. This is working. No, I need to get it to work. Yeah, that's fine. Equation is negative x squared plus 7x plus 2. Okay, if we graph that, what is our y-intercept? Kind of hard to tell. What's, yeah, 2, yeah. And you can go trace what, the y-intercept is when x is 0, right? Trace 0, enter on your graphing calculator is another way to get it. So trace 0, enter gives you a y value of 2. We can also find it without our graphing calculator with the same sort of idea. The x-intercept occurs when x is 0. And so if I plugged it into this equation, negative times 0 squared plus 7 times 0 plus 2, what does that give you? 2, because the rest is a 0 plus 0 plus 2. So that's why it's our constant and our y-intercept are the same thing in standard form. Only in standard form. Okay? Next guy, what's my a value? 2, so it opens up. What is my c value? 0. It's the constant. Is there a constant here? No. It's 0. Technically, there's a plus 0 here. Normally would not write that. And so what do you think the y-intercept will be? Yeah, if we plug in x as 0, it's just going to be 2 times 0 squared minus 5 times 0, which is 0. Yeah, it's our c value. Next guy, a is, you can do the rest. Fill in the rest. Okay, a value, first one would be up or down? Up. So because a value is 3 over 2, it's positive, it's going to open up. And the c value is 7, so the y-intercept is 7. Next one, a value is negative 1/3, so it opens down. You should have had your constant is negative 4, your c value, constant. So your y-intercept is also negative 4. So conclusions for a, if a is less than 0, it's going to open what direction? If a is less than 0, down. Okay. And if a is greater than 0, opens up. So that's the conclusion from there. And in standard form, c is the constant, which is also the y-intercept. Exactly. C, or your constant, is the y-intercept as long as it's in the form of y equals ax squared plus bx plus c. Okay? Has to be in standard form for that to be true. I feel like we should skip this one. Or do you want to try it yourself? How are you feeling? This is just, again, using your graphing calculator. Yeah, you know what? We haven't done graphing calculator stuff in a while. Let's just do it quickly. So let's grab your graphing calculator. We're going to list each one of these. It's been a while since we actually used some of the features in our calculator. Negative 3 x squared minus x plus 1. So first, take a look at that and tell me if your windows need to be changed. Oh, I forgot. Okay, so here we go. What's my a value in this equation? Negative 3. Okay, my y-intercept, just by looking at it, it's in standard form, would be 1. Y equals 1, or you can write that as a point if you want. X is 0, y is 1. X-intercept. Okay, how would I get the x-intercepts? on our calculator, because we haven't learned how to get them any other way yet. Second trace, and number, which one of these would give me the x-intercepts? Number 2. So we talked about this yesterday. Zeros are another name for x-intercepts. Zeros and roots. So number 2 is what you want. We'd have to do one at a time. So left side of the x-intercept. I'm going to do the left x-intercept. You want to be on the left side of it. Push enter. Let me just open up the other one so you can see it better. Okay, so left side, push enter. Then right side of the x-intercept and push enter again. So we're telling our calculator between these 2 points, can you find the x-intercept? And then the third one just says guess. You can push enter. You don't have to actually guess where it is. And it'll give you your x-intercept. Okay, so you should have negative 0.2 decimal places 77. Did you get that? Okay, find the other one now. You try the other one. So you should be going second, trace number 2, left side of it, enter, right side of it, enter, and then a guess. Well, you don't have to push guess, you just push enter. So did you get 0.43? Great. Okay, on our graphing calculators, to get the max or min value, we need to figure out the vertex. In this graph, is it going to have a max or a min? A max. It's opening down. So we're going to go again to second trace, and we're going to push number 4 in this case. Second trace number 4. Open up this guy. Okay. So it says left bound. So we want to go left side of the maximum. Left side of the max. Push enter. Right side of the maximum. Enter. And then it says guess, and you can just push enter at that point. You don't really have to. So you should get those 2 values. Now I'm going to show you something. Those are repeating decimals, it looks like. Maybe, maybe not. Well, especially the y value. So there is a way to turn these into fractions. I don't know if you knew that. So how do we do that? If I want it as a fraction instead of a decimal, because in this unit there will be times where it's going to be better as a fraction than a decimal. So right now I have negative 0. I'm just going to write this down. 0.167 and 1.083, right? Now on your calculator, automatically when you find a 0, an x-intercept, an intersection, anything, it restores your x and y values as these numerical values. So what I mean by that, if you quit out of here and just type x, enter, is that the same x value we had? Yeah. Or if you type alpha 1, which is the y value, enter. There it is. It automatically stores it. And so if I want to make it a fraction, I can go x, math, enter, enter. And guess what? That is not able to be made into a fraction. Now theoretically, your calculator is doing an estimated. Did anyone's actually turn into a fraction? Yours did? What was it?
13 over 12.
13 over 12? Anyone else? Because it isn't like, and depends how it actually calculates the max or min. Let's see, alpha y. Alpha y should, I think. Oh, okay, alpha y. So x doesn't, but y does. Alpha 1, math, enter, enter, is 13 over 12. So sometimes it can be turned into a fraction. We'll leave it as a decimal this time, but when we get to like things like completing the square, which I know means nothing to you at this moment, but will mean something to you tomorrow. Well, what's today? Tuesday? So Thursday, we'll start completing the square. This will be really helpful for you, okay, to check your work. So let's rate it as a decimal for now. Or you can write the y value is 13 over 12. Axis, oh no, what did I do wrong there? That's bad. Miss Johnson. Max or min, what should I only state? y. So max of 1.083. Just the y value. Or max at y equals just the y value. Axis of symmetry would be the x value. And you'd have to write this as an equation. This one, x equals, it has to be written as equation. So the p-value of your vertex. Oh, that's not the p-value. What was the p-value? Negative 0.167 right here. Here's my vertex. Okay, domain. Domain of any quadratic that does not have a context to it. What do I mean by context? In math class, something has context. Anybody? Guys seen Bueller? Is it Bueller's Day Off? Ferris Bueller? Good movie. Anyway, you'd like it. Okay. Well, domain of any quadratic that does not have context. Okay, context means like a word problem where there's an actual situation to it. So you're graphing height versus time, or you're like there's actual context to the problem, right? That can change the domain, because if you have a time situation, can you have negative time? No. But if it's just an equation, there is no context to this graph. How far left will this graph go? Forever. How far right? Forever. How do we write that? Thank you. X and elemented reals. The range will never be YER for our quadratic. It will be either y is greater than or equal to, or y is less than or equal to. In this case, is it going to be y is greater or y is less than? Is it going to go, does it keep going down or does it keep going up? Down. It's opening down. So it's going to be y is less than or equal to whatever the maximum value is, which in this case is 1.083. Okay? Yes. Let's go. Let's get moving. Okay. In this case, what's the direction of opening? In this graph, y equals x squared. So it goes up. So the a value is what tells us, right? That's how we know the direction of opening. So this is a description of how to find it on the left side, and we're going to find it on the right. Actually find it. Oh my goodness. Did you give me the thing? Nope. Okay. All right, to find the y-intercept, I want you to find the y-intercept. Okay. You don't need to use your calculator. What is the y-intercept? Negative 10. Remember, it's the c value. Okay? So your c value is your y-intercept, the constant. Or you could have set x equal to 0, right? The other way is set x. So it's the c value in standard form. Okay, I'm going to show you a different way to find x-intercepts. And one of the ways is, well, we know x-intercept occurs when who's 0, first of all? Y. So I'm going to set y equal to 0. So in our equation, let's set y to 0. Now, is it possible to isolate x here? Not really, no. There's two x's and one of them's squared. So what we're going to do is we're going to factor. This is going to something that's going to carry into the second part of the unit too as well. So we can use our graphing calculators to find x-intercepts, right? So on your graphing calculator, you use a 0 feature, right? Second trace number 2. We can do it that way. But I'm going to show you another way by factoring. Okay? So can we factor this? Do you remember grade 10 polynomials and factoring, Chinese method? We'll spend a whole day on factoring review, don't worry. So do you remember, okay, the x squared, two numbers, the coefficient is 1. So the only way to multiply to 1 with two numbers is 1 times 1. Agreed? Remember this? Your teacher might have wrote it differently. So we want two numbers that multiply to x squared. So it would be 1x and 1x, really. Right? 1x and 1x. 10, two numbers that multiply to negative 10, but add to the middle term of negative 3. 5 and 2, okay? Who has to be negative? So we multiply our diagonals have to actually, when you multiply your diagonals, so 1 times 2 is 2, 1 times 5 is 5, we need to make it add to negative 3. Who has to be negative? The 5? The 5, right? And so it's really FOIL, used backwards. And so each one of these is your factored form, right? Each row. So in this case, this would factor to x minus 5 times x minus 2. Okay? We will spend a full day on factoring review, I promise. So if this is like you don't, factoring is so important. I'm sure your grade 10 teacher said that. We're going to be doing, once we start factoring, you're going to be using it the whole semester, the rest of the course. So it's really important. So let's think about this. If you have two numbers, two things that multiply to 0, right? If a times b equals 0, what can you tell me? What has to be true? Either a is 0, or b is 0, or they're both 0. One of the three situations, okay? So let's think about what x value would make this guy here equal to 0. If x was equal to what? 5. Would you agree 5 minus 5 equals 0? So that's 1. So if x was 5, that product would be equal to 0. Because you would have, if you sub in x equals 5, you had 5 minus 5 times 5 minus 2, or 0 times negative 3, which is 0. Okay, the other one, what if this guy, we want this guy equal to 0? What would be? X would have to be 2. So if you did use your graphing calculator, you would have seen that your x-intercepts are 2 and 5. Okay, and that's going to be, basically, chapter 4 is doing this like every lesson. And different ways to actually do this. Find the solution. Find the x-intercepts. Okay? Can you use your graphing calculator at this point? Yes. Totally fine. Don't stress about that. Okay, so in standard form, can you see your vertex if it's in standard form? It's in the form y equals ax squared plus bx plus c. Can you look at that and tell me what the vertex is? Nope. Okay, standard form is really good for one thing, and one thing only. Your y-intercept. That's it. But really, it's the only thing it tells you. Okay, but there is some ways we can actually, in standard form, actually figure out what the vertex is. So if we think about our graph, we know that our graph has x-intercepts of 2 and 5. Okay? And with a quadratic, what's really cool about a quadratic, we have this axis of symmetry that cuts the graph in half. So if we have 2 points where the y values are the same, we can average the x's to find the middle. Okay? So if we know this graph opens up or down. We already said this. Okay? It's going to look something, we don't know exactly how it looks, but we do know it opens up. It's something like that, right? It opens up and it has an x-intercepts of 2 and 5. And so the axis of symmetry is halfway between 2 and 5. So we just need to average those two values. So how do I average? You add them together and divide by 2. So 2 plus 5 divided by 2 is, well, that's great. It's a decimal. That's okay. What is it? 3.5. 7 divided by 2 is 3.5. Okay, that's my axis of symmetry then. Because halfway, we know now the x-coordinate of our vertex has to be at 3.5. We don't know the y value, but we know the x. It's halfway between the x-intercepts. Because the axis of symmetry will cut it in half, and the axis of symmetry goes through our vertex. Okay, the other method is something you have to memorize. And that is negative b over 2a will also give you your axis of symmetry. So in the form of ax squared bx plus c, negative b divided by 2a. So in this case, what's my b value in this equation? Negative 3, and what was my a value? So if it's just x squared, what's the coefficient? 1. So x equals negative b over 2a, or negative 3. What will that turn into? Positive 3 divided by 2 times 1, or positive 3. Wait, something went wrong. I made a mistake in my factoring. Really quickly, can I change something? Did anyone see it? Negative 2 should be, it was a plus 2. Sorry. So this should have been a, what x value would make that 0? Negative 2. And so negative 2 plus 5 divided by 2 is 1.5. Sorry, guys. That makes more sense. These two should be the same thing. 1.5. This was the x-intercept, so my graph is even wrong. I'm sorry. Boo. Johnson. You know better. Your graph should have been more like this. Let's just erase it. I'm sorry. Please forgive me. Stupid mistakes. Okay, so halfway is actually 1.5. About 1.5. Right around there. Okay? Negative 2. Oh, Johnson. Okay, so that's the other way. There's two methods. Finding your x-intercepts and averaging them, or using negative b over 2a. Is that on your formula sheet? Heck no. That's why it says memorize. Okay? All right, so max or min, once you know your axis of symmetry, you can use that to get your max or min value, right? Do we know the p-value of our vertex? The vertex is at 1.5 comma something, comma q, right, our q value. We know the axis of symmetry, we know one of the values. So we can find the y value, how? By subbing it into our equation of x squared minus 3 times 1.5 minus 10. Okay, sub that into your calculator and see what that gives you. We expect it to be a negative because it was opening up. I had x-intercepts. You can answer as a decimal. You don't have to write it as a fraction. Gives us what? Did you get it? Negative. Good. Negative 12.25. So it's in this case because what direction does it open? Up. So it's going to have a min or max? Min at y equals negative 12.25. Okay. So do we need to sketch this? Let's skip the sketch and move on. It's not the greatest graph because our minimum is below the graph anyways. Let's move on. Okay, so just to review, to find the axis symmetry when it's in standard form, either find your x-intercepts and average them, or negative b over 2a. And then to find the vertex, you plug in that number. So by that number, I mean the axis of symmetry value. Okay, what we just found, in for y, and then you have your vertex. So that's the big portion of that. We just need to finish this page. I want to kind of move a little quicker. So we're going to use negative b over 2a because it actually is less work than trying to factor or using our calculator to get intercept. So to find the axis of symmetry, let's, for each one of these, plug it into negative b over 2a. I'm going to get you to do that. Okay, figure out your axis of symmetry for each one of these. So start with that. Be careful if you're typing this in your calculator, because if you are, remember your calculator needs brackets around your denominator. So if you were typing, so let's say negative 3 over, well, this one, the first one would be okay, but like the second one, negative 4 divided by 2 times 2, it's going to give you an issue. It's going to give you 4 because your denominator needs to be wrapped in brackets, right? So you'd have to do divided by bracket 2 times 2 if you want to type it in your calculator. It's almost easier just to simplify it without your calculator, right? It's pretty easy stuff. So you should have 1.5 for the first, a 1, and negative 2.5. Do you agree? Same thing? Okay. And so to get your vertex, what would we do? How would we get our vertex from this point? If I know my axis of symmetry, I know my p-value. What would I do? Put an x for your equation, right? Just sub in the x value. So in this case, it'd be negative bracket 1.5 squared plus 3 times 1.5 plus 2. Okay, we just sub it in. Now to save time, is it okay if I just give it to you? Yes, okay, you're not against that? Oh, I have 35 over 4. What is that as a fraction? 8.75? I don't know. Darn it. I are in fraction form. Yay! Did it. Sometimes my brain works. Earlier it didn't. Okay, so that would be our vertex. 1.5, comma, 8.75. You can, sometimes it would actually prefer that as fractions, but math enter will do that for you, right? So next one, subbing in our axis of symmetry of 1. This one we can do in our head. 2 minus 4 is negative 2. 1 and negative 2. Okay, this guy, I might need you to, I don't know if I did it right on my work. So let's do this one really quickly. Bracket negative 5 over 2 squared plus 5 times negative 5 over 2 plus 6. Okay, negative 0.25. So our vertex would be negative 5 over 2 or negative 2.5, comma, negative 0.25. What's wrong? Did I do something wrong? Question? You sure? Yeah? Okay, let's check. 1.5 squared, the negative, oops, got decimal. Okay, negative 1.5 squared plus 3 times 1.5 plus 2. It's a negative? No, it's a positive. Because you had a negative b over 2a, and so the two negatives would cancel each other out. Oh, yeah. Did you get 4.25? Okay, that's why you're questioning me? That's good. I don't know. I have no idea. Everything's written right, but my answer's wrong. Sorry. I got so excited because I like, oh, I did this in my head, no big deal. It's wrong. Pride comes before fall. tell ya. Okay. This one is basically from yesterday's lesson, so I'm going to skip it because we have our PQ, we have an XY, right? It's solving for A, and there's your equation. It's the same stuff. So let's skip this one and go to the last one. All right, we have 2 points. I'm just going to roughly sketch them. -1 and 12, and then 7 and 12. That's all we know. What is the axis of symmetry? How could I get it? David, do you need to put that on my desk? Okay, thank you. Axis of symmetry. What do you know about the axis of symmetry? It's pretty. Wait, what? It's halfway. Okay, it's halfway. What else do you know about it? You love it? Yeah. Right down the middle. It's vertically down the middle. Okay? It's vertically down the middle. So, if the y values are the same, can we get the axis of symmetry? Yeah, how do we do it? Average what? X values or y values? Average the x values. Okay, if the y values are the same, we just average them. We want halfway between. So -1 plus 7 divided by 2. I don't trust myself. Did you get 3? I don't right now. Yay. Okay, x equals 3 would be halfway. Does that make sense? Yeah. 4 away. 3 plus 4 is 7. Then 4 away to the left to bring you to -1. That's halfway. So that's how we get it. Okay, so that's a great test question. I just give you 2 points, say find the axis of symmetry. All you have to do is average them, find the middle. Love that question. We're finally done. I'm sorry it was long. Okay, so the assignment for today is on page 174. It starts 1 to 3, 4 AD, and 5 AD. I think you'll find it pretty simple. Hopefully.